Our next speaker is Dr. Anna Yusupova, and she's a lead scientific researcher at the Laboratory of Cognitive and Social Psychology with the Institute of Biomedical Problems, or IBMP, in Russia. And she will be giving us their latest findings with an overview of Russian confinement experiments and major psychological insights. Thank you, Dr. Yusupova, for being with us.
So today we'll be talking about the Russian confinement experiments, the ones that became history already and the ones that are going on right now. And I will explain what do they give to the present space missions and what can they tell the interplanetary program that's being prepared. So first of all, what are the experiments in hermetic chambers, so-called confinement experiments? They simulate effects of long-term space flight, such as sensory deprivation, monotony, confinement, social deprivation, controlled artificial environment, in order to study their influence on crew members' behavior, activity, physiological and psychological state, and their interaction. So, yes. Why not to study all that directly in space? Well, first of all, because there is a lack of time for studies in space flights. Second, there are restrictions on equipment mass and dimensions. As you know, it's quite difficult to ship onboard equipment that's necessary for research. Also, there is a very important problem. There is a lack of crew members' interest in some testing procedures. And it was repeatedly noted in the works of Soviet and Russian psychologists and, well, scientists in general, because basically cosmonauts are afraid of being excluded from the space program because they wouldn't match some criteria, for example. And so also, in addition, there is an image of a flawless hero that it, of course, excludes problems with fatigue, pain, problems with mood, etc. And so this also prevents cosmonauts to participate in certain studies. Well, what do we target in isolation experiments as psychologists? What are the main interests? What are we searching for in confinement experiments? Well, first of all, we are interested in finding best ways to organize cosmonauts' work in flight. And so, taking into account that the astronaut is well, their life is quite complex on board, and they have to master a lot of different skills and even professions. It's very intense. How to organize the schedule, how to make it fit from one side the plans that should be done, and the health, psychological and physiological health of the crew members. This is the first thing, well, the first question that we target. The other one is the stress factor of limitation of living space, of the volume, confinement itself. Because as the personal space suffers in confinement and leads to stress, we have to understand how does this stress influence the behavior of the crew members and what can we do with that. So confinement experiments are a better environment to study these issues than space flights themselves. Also, what we can, for example, study in confinement experiment is the noise level, because as you know, at the ISS, the constant noise level is about 60 decibels. It's a lot. And so the questions of influence of noise on performance and mood are also, these questions are also very interesting, and there are always studies about that. Also, of course, we want to study the effects of social isolation and the confrontation with the social contexts that are imposed from outside. So you cannot really choose who you will be talking to throughout all the isolation. This is also a very important issue that may cause a number of quite difficult problems, and this is why it is quite important to study that in an isolated environment. Of course, we also look at the interpersonal interactions in the crew, because the crew cohesion is one of the main points, that main keys to success for every mission. And so how to build the crews, how to prepare the crews so that they work together in a very good way throughout the mission. This is all the questions that we are interested in. And so about the space simulations themselves.
Should I go on to the next slide, Anna?
No, not yet. Just 2 words.
Okay, sure, no worries.
Thank you. So as you see on the picture, there's this strange thing on the picture. Actually, this is the picture of the chambers, the schema of the chambers that we are making our experiments in. This is the modern state of these chambers, but it was not always like that. So when the confinement experiments in IBMP started, the chamber was one, and there was only one chamber, and it was very small. So now we can go to the next slide. So the experiments started in 1960s, and one of the first one already was an annual experiment, an annual isolation, and it stands out as the longest one before the Mars 500 project. It was made to support the Soviet Martian program, of course, and the chamber was very, very small and quite unfriendly. For example, the walls were covered with steel just for hygiene. And a modern bioethical committee would never authorize this layout now. The main results were physiological, and these results were really priceless at that time in the 60s. For example, we discovered some major, very important information about health and mood under increased level of CO2. Also, one of the most important psychological findings was about the crew composition. We found out that it wasn't a good idea to make a crew of 3 people, because in every given moment, there were 2, as we may say, friends and 1 outsider. And this 2 against 1 composition was changing throughout the experiment. But of course, it was not at all good for the psychological climate in the crew. It was really, well, it affected the psychological state of the crew members. In the 70s and in the 80s, about 11 chamber studies took place in IBMP, lasting from 5 to 120 days. And they was focusing on various aspects of spaceflight organization mainly. So now we can go to the next slide. In the 90s, the chamber studies in IBMP became international. And they simulated international missions. So on the next slide, normally you can see some information about this, a couple of experiments. Yeah, thank you. International experiments of that decade. So Hubis was taken by IBMP together with ESA, European Space Agency, and it stimulated the European cosmonaut flight on Mir orbital station. And the everyday life and all professional activity conditions were organized with a maximum correspondence to the real space flights. In fact, it was a check of the schedule, and in order to understand if what we think on Earth, the schedule that we think about on Earth, would be okay, taking into account the presence of European cosmonaut. So, as in the yearly experiment of the 60s, a crew of 3 again was found to be a composition with 1 outsider. So again, it was not a good idea. But also, what was found in this experiment was the so-called third quarter phenomenon, third quarter effect. Nick Candace was the researcher who found it in this Hubis experiment. And it was really an interesting finding because this phenomenon was considered to be a typical phenomenon for polar winterings, for Arctic explorers. It is associated with impairment of psychological and physiological state throughout the third quarter of the mission. And normally gives consequences like dysphoria, sleep disorders, mood disturbances, and performance is affected a lot, motivation as well. So people are really not in a good state during the third quarter in polar winterings. And it was a really interesting surprise to find it in isolation experiment. The ECOPSI experiment simulated visiting crews and included sleep deprivation. But in this experiment, it was found that greenhouse that was also in the chamber was extremely important for the crew members. In a fully artificial habitat, the plants attracted a lot of crew members' positive attention. It was also seen in yearly experiments because they also had a greenhouse. But here, crew members consider the greenhouse presence to be a real psychological support. Next slide, please. So the next experiment was Sphinx 99, and it was organized to prepare for the ISS missions, to simulate the multinational mixed gender crews' behavior and performance on ISS, in order to obtain data on effects of long-term isolation on international crews' interaction and performance. And here it was made with participation of a European Space Agency as well as Canadian and Japanese space agencies. So it was really a big international experiment. And this experiment gave a number of results that were in fact negative, but they contributed a lot to ISS rules and planning. Well, first of all, cultural differences led to very weak crew cohesion, provoked subgroups, caused conflicts between crews and crews with mission control. In three crews, there was only 1 woman, and all other crew members were male. And this created additional conflicts and destabilized the crews even more. So this makes us think that 1 woman in a completely male crew is not a good idea as well. Also, the experiment aimed to check if a flexible planning would work better for the future ISS crews. But the results showed that flexible planning is less efficient and causes undesired psychological and physiological even effects. So this experiment, the Sphinx, was full of, well, in fact, negative surprises. But all these lessons from this chamber experiment served for ISS organization and methodology. For example, analysis of crew conflicts led to creation of the ISS Code of Conduct. Also, mistakes made in crew members' selection contributed to ISS selection and training of crews. Also, as well as management structures and personnel maintenance. Really, well, we really worked a lot with our international colleagues to make the maximum use of the mistakes that we made. And in fact, finally, both in future modal studies and international on the ISS, the lessons from Sphinx 99 were very useful. So now next slide, please, about Mars 500 experiment. It was organized, well, practically 10 years after the Sphinx 99. And the main goal was to simulate an autonomous flight to Mars. This experiment was organized using all the lessons we had in Sphinx. The crew had a lot of team making to ensure that the crew cohesion would be good. And in experiment, the crew cohesion was really good. What was new in this experiment compared to the previous ones? These were the autonomous existence conditions. They were simulated by limiting the amount of available resources, food, consumables, and spare parts, etc. There was no additional equipping after 36 days of flight. The most important is that for the first time, there was an increasing communication delay between the control center and the crew in order to simulate the real flight to Mars, where we will certainly have a communication delay. And during the experiment, the delay reached 16 minutes. On days 320 to 327, there was a complete cessation of audio communication. There was no audio communication at all for a week. So the crew could only use emails and video messages that also arrived with delay. So other innovations of this experiment were simulations of landing and EVA on Martian surface. It was more or less in the midway of the experiment. So the main psychological results, the most important was so-called Earth out of view phenomenon. It was described by Canis and Mansi, but studied for the first time. What was it expressed in? Well, first of all, the motivation and general activity decreased, while distance and autonomous conditions like, well, for example, communication delay, increased. Second important result was that the crew members had an increasing sense of isolation, separation from Earth, from relatives and from friends, although they knew that they were only confined. They were not on their way to Mars. And the third important result was a rise of groupthink. The crew became more and more independent from the mission control recommendations. And well, they got more independent in their decisions. Mars 500 became the first study of communication delay influence on information transmission efficiency in intergroup relations. It was shown that it's not the length of the communication delay that is important, but the fact of its presence and inability to immediately obtain the needed information leads to change of attitude towards mission control. Both sides experience a feeling of dissatisfaction with communication. Also, the crew gets no correction of their decision from external point of view, and well, it is a part of normal communication. So finally, the communication gets, well, as we may say, broken in some kind. And the total disconnection from the communication for 7 days led to a decrease in information flow towards mission control and about what was happening in the chamber. And it was difficult for mission control to make decisions and to support the crew in a good way. So also this experiment confirmed in some sense the concept of salutogenesis by Antonovsky, that indicates that passing through difficult, dangerous, psychological, traumatic situations can lead to significant psychological advantages for those who had overcome these situations. Mars 500 crew members, as well as astronauts and cosmonauts after real space flights, demonstrated an increase in confidence in their own efficiency, ability to cope with difficult problems, and better stress resistance. So after Mars 500, IBMP organized several successful experiments with different crew composition. For example, experiment named Luna 215, Luna is Russian word for moon, simulated a flight to the moon of a crew consisting of 6 women. Also, together with NASA and ESA, we are now making a series of experiments named Sirius. These experiments simulate flights to the moon and various elements of planned lunar program. Now we are preparing the third one, an 8-month experiment. In all serious experiments, crews consist of 3 men and 3 women. And for now, we have already finished 2 experiments, and for now, these crews work really good. By the way, Anastasia Stepanova, who will be giving a talk on Sunday at 10:30 a.m., was a crew member of Series 19, a 4-month isolation experiment that simulated a flight to the moon, flyby, and search for a landing site, landing of 4 crew members for surface operations, staying in the moon orbit to receive transport ships, etc. So on Sunday, Anastasia will speak about the dry immersion experiment where she recently participated, and I'm sure it will be really interesting. So don't miss the talk. So next slide, please. How can we apply all these results to make a better mission to Mars? Well, first of all, we should keep it in mind that orbital and interplanetary missions are completely different in terms of equipping and general help. In our society, we're used to get what we need quite fast. Deliveries work well, even if there's a lockdown. We get angry when we cannot deliver in time what we want, and we can call anyone and expect to get a very quick answer when texting. But orbital missions are not so far from this concept, because we all know that if something goes really wrong, the government would just ship the needed equipment with another spacecraft. It's still possible, even if it's expensive. In interplanetary flights, it just is not possible. So the first issue here is resources management. First of all, it's about the capacity to use and reuse the resources, to fix what's broken, the manual skills. And basically, in our society, we're not very much about manual skills. Second, it's about crew dynamics around these resources, because who has a right to take what? This may lead to subgrouping and severe conflicts.
5 minutes.
Yep. So the code of conduct made on Earth prior to the flight is quasi-obligatory. We've seen examples of resource conflicts in classical Arctic expeditions. I suppose you read about Nansen, Amundsen, Scott, Shackleton, and how did they manage conflicts or did not manage, and what did it lead to? And just like in Arctic missions, boredom would be a very important issue that has to be taken care of, only if we wouldn't invent hibernation. Boredom may be destructive, and boredom in sensory deprivation can lead to severe consequences as well. We can also learn that from Arctic missions. There is a good possibility of third quarter effect appearance in interplanetary missions as well. Imagine that, for example, a large part of the crew has low motivation and is in constantly bad mood. This may not be an effective crew. So one of the main ways to prevent and to fight boredom is to be occupied. Perhaps one of the possible decisions is to learn in flight. New skills, new profession maybe, that may be useful for the group in order for the group members to be interchangeable. Also, one of the points that are very important is about creativity and independence. This is a point that is about the selection procedures. We still we're not very sure about what we will find when we will land on Mars. So we have to be ready for, of course, for different scenarios, but there should also always be some space for creativity and for improvisation. So this point about crew selection is quite important as well, because skilled and creative crew would be the key for future mission success. I think that's it. If we have some questions, I'm ready to answer.
Okay, great. Thank you for your time. So the first question is, has there been any study on kind of what you can do to condition or train the astronauts for these conditions psychologically?
I think I missed the part of the phrase. Could you please repeat?
To train or condition people for these long stints of isolation in small groups? Any study on that type of situation?
Well, we have quite a good experience on training crews for ISS missions. So it is quite difficult to make a study, because if we're making a study for example, where we want to train people for long-term missions, we also should make some long-term missions, because in order to prove if we made a good, well, if our effort was a good one or not. So for a present moment, we know how to create groups for 6 months. I think that as soon as we would get some real information about planned interplanetary flights, we will of course start to prepare the real mission. But the studies on crew selection, well, basically they cannot appear, because we don't have a control and experimental group in this